Okay, good morning, students. Yesterday, about manufacture of ammonia by Haber's process and chemical properties, uses of ammonia explained. Last in ammonia for objective very important, and also practicals very important. It is not there in our syllabus right now in PUC textbook. In practicals very important. This is only for objective and practicals. That is test for ammonia. So the test for ammonia in the laboratory, this ammonia is present in a zero group. In laboratory, for the detection of basic group radicals, in this detection of basic group radical to identify the ammonium ion, NH4 plus ion, generally, one important simple preliminary test is there for the detection of ammonium ion or ammonia, presence of ammonia. For example, take in one test tube ammonium related solution, salt solution to this. This is ammonium related salt solution. This is NH4Cl, maybe ammonium chloride. And to this add some amount of water, H2 and a little bit NaOH. Just heat it. This is just heat it. And in laboratory, the hydrochloric acid solution is available. This is HCl, concentrated HCl solution. Take the glass rod. This is the glass rod. Now this glass rod dipped into HCl solution. That the glass rod is exposed to the mouth of this test tube. Exposed to this mouth of the test tube. Then immediately it produces white dense fumes. White dense fumes produces. Dense fumes. So that indicates white dense fumes indicates the given salt, unknown salt contain ammonium ions for the detection of ammonium ion. Confirmatory test for this, CT for ammonium ion, NH4 plus. For this confirmatory test, we can use Nessler's reagent. This Nessler's reagent, a ready-made solution available in the laboratory. That Nessler's reagent is generally prepared by using potassium iodide plus your HgCl2 plus, potassium iodide, HgCl2 and NaOH. So by using this combination, we'll get Nessler's reagent is K2HgI4. This is combination, Nessler's reagent combination. So in Nessler's reagent, here potassium iodide, mercuric chloride and sodium hydroxide combination. Finally, we'll get this one complex like K2HgI4. This Nessler's reagent is added to the test tube containing a unknown salt solution. That solution may contain ammonium ion like ammonium chloride. So to this Nessler's reagent is added like K2HgI4 is added. Immediately it forms a reddish brown precipitate. A reddish brown PPT is formed. That reddish brown PPT formula is the HGO, HG2O and NH2I. This is the Millen's base of iodide. This is the Millen's base of iodide. So detection and confirmatory tests in the laboratory in second PUC, zero group elements, so very, very important. Ammonium bromide and ammonium chloride, two salts in that. Detection of basic group radical, ammonium ion, we can use. This is the preliminary test, identification. This is the confirmatory test for that. That is ammonium salt solution just heated with the help of sodium hydroxide and to these concentrated hydrochloric acid glass rod is exposed to this white dense fumes are liberated. That indicates presence of ammonium ion. Further confirmatory test is this. This is for practicals in the laboratory as well as objective purpose importance. So this is the complete explanation about hydrides of nitrogen. Then next very, very important topic is oxides of nitrogen. Okay, clear? Here in these oxides of nitrogen, 6 important oxides are there. One is dinitrosan oxygen or nitrous oxide, nitric oxide, N2O3 nitrosan trioxide, nitrosan dioxide, nitrosan tetroxide, Nitrogen Pentoxide. These are the 6 important oxides. So I'll create an important table for this. Complete preparation, oxidation state, and nature of these corresponding oxides of nitrogen. Each and every one oxides, preparation methods and everything. Better you make a table, an important table, and read the same table that is useful for PUC as well as objective. First one is type of oxide. Type of oxide or preparation method. Preparation method and its nature generally. Type of oxide and its oxidation state also. Here I'll take oxidation state, 4th column. Here oxidation state of that nitrogen. Now this is an important table for oxides of nitrogen. First one is dinitrosan oxides, or here we can use nitrosan 1 oxide. This is also called a laughing gas. Laughing gas. Now make like a table for this, like. Now, these are the 3 important points. Yeah, nitrogen 1 oxide means, yeah, its symbol is N2O, like. Oxygen is -2, only 1 oxygen is there, compulsory for nitrogen +1 oxidation state. That's why its oxidation state is +1. Okay. Now, it is prepared by using ammonium nitrate, NH4NO3 on heating. We'll get here the 2H2O water molecule plus N2O is formed. This is the gas. N2O is gas. So preparation of nitrous oxide. This is also called a nitrous oxide. Here the nitrous, I'll write here nitrous oxide. This nitrous oxide, laughing gas, nitrogen 1 oxide, dinitrosan oxide. Preparation method is this. Ammonium nitrate on heating will get the water and this gas. It is a neutral neutral, colorless gas. Colorless gas it is. Clear. So based on this, if they'll ask any story, what is the main name and oxidation state? How do you prepare this nitrous oxide by using ammonium nitrate, means reaction and its nature. The next one is second oxide is nitrogen oxide monoxide. Nitrogen monoxide. This nitrogen monoxide also called nitrogen 2 oxide. This is also called a nitric oxide. Nitric oxide. Now this nitric oxide formula is NO. Oxygen is -2, compulsory nitrogen is +2. That's why its oxidation state is +2. Very, very important. Now, this is prepared by using ammonia. 4 moles of ammonia gas is oxidized with oxygen at certain temperature and pressure on heating by using catalyst. This is a very, very important reaction. Next coming nitric acid is there I will explain. Then here it gives here the 6 H2O water molecule plus 4 NO is formed. This is the nitric oxide gas. It is also a neutral gas, neutral colorless gas. Colorless gas it is. So the second one is nitric oxide, oxidation state is +2 and is prepared by using ammonia gas and oxygen, are also prepared by using 2 moles of sodium nitrite plus 2 moles of FeSO4 plus 3 moles of sulfuric acid. It gives are the 2 NaHSO4 plus Fe2SO4 taken thrice plus NO is formed. Nitric oxide is formed. Are the 2 moles of nitric oxide is formed. Same, it is a colorless. But you remember any one method for this. Then third one is your dinitrosan trioxide. Dinitrosan trioxide. This dinitrosan trioxide, third oxide. This is called nitrogen 3 oxide. This is also called very, very important nitrogen suswick oxide. Suswick oxide, this is very, very important. Its formula is N2O3 here -2 +6. Compulsory it is required +3 oxidation state. That's why here its oxidation state is this. Now to prepare N2O3, we can take your combination of your NO plus NO2. This is. Now on heating these two gases, we'll get N2O3 trioxide, nitrogen trioxide will get it. N2O3. Now it is at our room temperature. At our room temperature, it is blue color solid. Blue solid. At a high temperature, it is blue color gas. Blue gas nature. So these are the 3 important oxides of nitrogen. Next, the same table I will create remaining 3 oxides. That is nitrogen dioxide, nitrogen tetroxide and nitrogen pentoxide. I'll make again one more table, better you note down. Here also same 4 columns. One is corresponding oxides, their oxidation state, preparation method and its nature. There are type of oxide oxidation state, preparation method. This is nature of that oxides. So the fourth one is nitrogen dioxide. Nitrogen dioxide. It is nitrogen 4 oxide, it's the name. Now its symbol is NO2. Now its oxidation state is +4 because here -2 into 2 -4, it is compulsory +4. Now preparation method for that. For this nitrogen dioxide, we can take lead nitrate PbNO3 taken twice, 2 moles. On heating this, we'll get 2 PbO lead monoxide plus oxygen plus here NO2 is formed. Here 4 are there, 4 NO2 balanced it is. Now it is a acidic. This is third one is acidic in nature. It is not on this. It also it is acidic in nature, acidic, and its color is a reddish brown color. A reddish brown color gas it is. A reddish brown color gas. This is the fourth one, nitrogen dioxide, nitrogen 4 oxide. Then here fifth one is nitrogen tetroxide. Tetroxide, or this is also called nitrogen 4 oxides. Its oxidation symbol is here N2O4. Here also its oxidation state +4. +4 oxidation state. Now generally N2O4 is prepared by using NO2 only. Dimerizes. Yeah, the reddish brown color gas obtained in this fourth case dimerizes. 2 moles of these dimerizes. Gives here N2O4, nitrogen tetroxide is formed. Dimer means 2 molecules dimerizes. Why here the NO2 is dimerase? 2 marks question is there. There I will explain at the end of this table. Very, very important. Finally, here the sixth one is Dinitrosan Pentoxide. In this Dinitrosan Pentoxide, oxidation state is 5. That's why nitrogen 5 oxide this is. Formula is N2O5, here -2, -10, compulsory +10. That is each nitrogen is +5. That's why oxidation state is +5 oxidation state. It is prepared by using HNO3 nitric acid, that is 4 moles. Reacted with P4O10 phosphorus pentoxide on heating. We'll get here 4H3PO4 plus here N2O5 is formed. 2 moles of N2O5. These two are acidic in nature, acidic in nature, colorless. It is also a acidic in nature, colorless. This is a very, very important table for PU or theory as well as objective, any objective. Oxidation state of particular oxides, preparation method and its nature, very, very important. Just 2 minutes, observe it and note on this table. And in our textbook also, in NCERT textbook also given all these and oxidation states and preparation methods. Maybe some more other methods are possible or available, but in our syllabus in textbook given like this, better you read and remember these preparation methods of different oxides. Okay. Clear? That is oxides of nitrogen. Your question is, this is a very, very important question. Why your NO2 gas is dimerizes? Why NO2 is dimerizes? For that we want resonating structures of oxides. After resonating structures of oxides only, we'll get the clear idea about dimeric structure of NO2, nitrogen dioxide. See here, after oxides preparation method, resonating structures for objective important these are. They'll gain examination. Which of the following is the correct resonating structures of N2O or NO2, N2O3 like? So next important concept is resonating structures of oxides of nitrogen. We know 6 important oxides of nitrogen are there. Just like preparation method, I'll create one table for resonating structures like type of oxides. Your type of oxide and resonating structure, structures of these corresponding oxides and its nature generally. Here type of oxide, first oxide we know N2O. So in chemical bonding, first year explained about resonance and resonating structures. So the redistribution of electrons around the atom of an element present in a molecule, that is resonating structure. To write the resonating structure, compulsory we want atomic number and the number of valence electrons and Lewis dot method. So by knowing this number of valence electrons and atomic number and Lewis dot structure only, easy to redistribute the valence electrons around one atom of element present in a molecule. For example, here nitrogen and oxygen are 2 elements only present in all these oxides. That's why nitrogen atomic number is 7 electronic configuration, 1s2, 2s2 and 2p3. In its outermost orbit, how many valence electrons are there? 5. Its Lewis dot structure is like this. This is the Lewis dot. This indicates this is the one is paired. This is the paired, one is paired. And remaining 3 are present in p subshell. These are unpaired. 3 are the unpaired. 2px, 2py, 2pz. That story we want. Then oxygen atomic number is 8 and its electronic configuration 1s2, 2s2 and 2p4. In its outermost orbit, 6 valence electrons are there. 2 are here, 1 is paired, and in p subshell also 1 is paired, remaining 2 are the unpaired. Total 2 paired and 2 unpaired. For this Lewis dot structure is, this is 1 pair, this is 1 pair, 2 pairs, remaining 2 are the unpaired. So by knowing that atomic number and electronic configuration, Lewis dot structure, easy to analyze, easy to write the resonating structures for that oxides of nitrogen. First, I will take care of the type of oxide, that is N2O, dinitrogen oxide, monoxide, laughing gas. For that, 2 nitrogen atoms are there. First, I will write 2 nitrogen atoms and 1 oxygen atom. Then, how it changes. Again, here nitrogen and oxygen like this. So, in textbook, maybe this is present here or this is maybe here. Whatever it resonating, anywhere we can write. First is this or last is whatever it. Now first I will take care on oxygen atom. Here this is the oxygen atom. Here nitrogen atom. Here we know these are the separate like this Lewis dot structure for Lewis dot structure for nitrogen and oxygen. For our convenience, we can write to get the stable octet electronic configuration. sharing between two atom of elements, we can take that sharing. For example, I'll take here, listen here, these three are, I'll connect with these three, it forms a triple bond. It forms a triple bond means nitrogen always forms a triple bond. Again, it forms one double bond, not possible. That's why here among these, I'll take one coordinate covalent bond as well as one by using these valency electrons. Here I'll take here one is like one bond, double bond. I'll take paired it is. One is. Now remaining here three are there. With this three, I'll take here remaining electrons, only one is there. One is connected like this. These two are donated like a coordinate bond. With this, one single electron and one is connected with this. Or one more type also we can write. Depending upon the Lewis dot structure, number of valence electrons, like this is the resonating either side we can write. Here a lone pair of electrons are we can write like this. Here one is a lone pair. These three are connected with this. Yes, it is correct. First one is given like, or second one. Second one. First one is given here a double bonds. Okay, this is first one or second one? Second one. Okay, so second one is given. We can write first one, choice was for understanding purpose. And our textbook given here triple bonds, but here I'll take a triple bond. Choice was. Now here one lone pair is there. Here two are the unpaired. These unpaired are paired, and here one vacant orbital is there. This is connected with this. One coordinate bond is formed. Clear. Either side, maybe right here like this, and here one coordinate bond, and here a pair of electrons. Take like any one, or change here, whatever it is. For understanding purpose, given any one we can write. For example, here Lewis dot structure, nitrogen, here nitrogen and here oxygen. Create like first, and here also nitrogen and oxygen like. Now here lone pair of electron is present, one is connected with this, one pair is donated to this, it forms a coordinate bond. Then here two are the nitrogen and nitrogen is present, here also nitrogen and oxygen, nitrogen, oxygen, here the two are the paired. This is. Or here pair of electrons, it is bonded with this, like only one is coordinate bond is present, remaining everything is same. So in this, once we can observe this is paired, all are paired, all are paired, all are paired. That's why its nature is diamagnetic in nature. This gas is diamagnetic because number of unpaired electrons denoted by a symbol N, that unpaired electrons are 0 electrons. So repelled by the magnetic field because all are paired. That's why here it is a diamagnetic in nature and it is a linear geometry, linear structure. That is a story about first oxide of nitrogen, N2O. Then second one is NO, nitric oxide. Here it contains only one nitrogen atom, one oxygen atom, nitrogen and oxygen, and here nitrogen and oxygen is present. See here on oxygen atom, here the 6 valence electrons are there, and on nitrogen atom here total 5 valence electrons are there. Out of 6 valence electrons of oxygen, yeah, these two are bonded with this. One electron is unpaired. It is unpaired electron is present. That's why here N is equals to 1 electron is there, unpaired electron. Now this is paired and this is paired, but on nitrogen atom one electron is unpaired. Here we can write like this, here nitrogen and nitrogen, here these are maybe one is paired only out of this is paired, nitrogen atom is paired, this is paired, this is paired, and it is paired. Oxygen containing two unpaired electrons, among these two one is connected with this, only one bond is there. Now it is one unpaired is there total. Either forms of NO, number of unpaired electrons or one unpaired electron is there. That's why it is a paramagnetic in nature. Gas is paramagnetic because number of unpaired electrons 1 shows magnetic moment attracted towards the magnetic field. It is also a linear geometry. So this is second important resonating structure. Third one is your N2O3 trioxides. Your nitrogen atoms are two are there between nitrogen and oxygen atom. Here two oxygen atoms and here one oxygen atom creates like. Now here also N and N, here two oxygen atoms and here one oxygen atom. One doubt, why sir here this side only two oxygen atoms are represented, why not this side? Means take this side also, no problem. Choice is either sides. So here the N2O3, take here like this one side, create set up one side two oxygen atoms, or these two oxygen atoms, better you write this side, choice is. So according to the Lewis dot structure, we know here this nitrogen compulsory between this one bond exists, and here on nitrogen atom one lone pair is there, and remaining two electrons are there. These two electrons are bonded with one oxygen atom. It forms one double bond. On oxygen atom two lone pairs are there. Now here also oxygen and oxygen between oxygen and nitrogen one double bond is formed. Again here the two lone pairs are present. Here nitrogen containing one lone pair, that is donated to this. It forms a coordinate bond. Remaining here three lone pairs are present. This is the correct N2O3. Now this is a resonating structure, same as it is here. Any one change it, here coordinate bond is there, redistribution of electrons differs, this coordinate bond take here, that's all, everything is same. This coordinate bond is take here in another structure, this is as it is. That's why here double bonds and two lone pairs, and there is even covalent bond between nitrogen. Instead double bond here, take here double bonds, then it forms one double bond and here one coordinate bond. This is resonating structure of N2O3. So it is angular in shape or angular planar structure, not planar geometry. This is. Here also all are paired. This is paired. All are paired. There is no unpaired electrons. So N is equals to 0 electron. That's why it is a diamagnetic in nature. Clear it is? Diamagnetic. Like create all oxides resonating structures. In objective examination, they will create questions based on this. Which of the following is the correct resonating structure of corresponding oxide? Then next fourth one is here NO2, type of oxide NO2. In this NO2, one oxygen, one nitrogen and two oxygen atoms are there. Now here this nitrogen atom generally NO2 is dimerizes. Why it dimerizes? Here nitrogen and here oxygen, also oxygen we can take here nitrogen, oxygen and oxygen. Oxygen here oxygen nitrogen here oxygen and oxygen like. Now here the between nitrogen and oxygen, here maybe here in between there exists even double bond like this. Now on oxygen atom, total 6 valence electrons are there, 2 are paired, 2 are bonded with nitrogen. On nitrogen atom, total 5 are there, 2 are bonded, remaining 1 is there. That one cannot. If it is bonded with this oxygen, it forms a single bond. But here among this one electron on nitrogen atom as it is, for this oxygen atom, this nitrogen atom donate pair of electrons to this, it forms a coordinate bond. One electron is unpaired, it is. Unpaired, that is n is equals to 1 electron, that is odd number of electron. Now instead of this, here in this case double bond, better you take here double bond and here a coordinate bond. Here also 1 electron is unpaired, it is. Now here same here valence electrons, and here also same valence electrons are present. Here complete in these 2 structures are nitrogen atom, 1 unpaired is there, that's why it is a paramagnetic in nature and is angular shape it is. So why, question based on this they'll ask why your NO2 dimerizes and it gives N2O4, give reason. So due to the presence of odd number of electron in its resonating structure, odd number of electron due to the presence of odd number of electron, 1 electron in its outermost orbit in its structure, these 2 molecules are dimerized to get the stable N2O4 molecule like this. Your nitrogen double bond O and it is the coordinate bond, your 1 electron, and another molecule also, this is 1 electron is present. 1 molecule of NO2, here donate 1 electron to the another molecule of NO2, equal contribution, equal sharing takes place, it forms a 1 covalent bonds. So this is the dimeric structure of NO2. This is the 5th important resonating structure. So the dimeric means 2 molecules are there. This is the NO2 molecule and it is NO2 molecule. It is dimeric structure. So the dimeric structure of NO2 means N2O4, that is due to the presence of odd number of electron, 2 marks, very important question it is. Okay. Last finally N2O4 and N2O5 resonating structures. Very important table it is. Resonating structures are very important. Particularly for objective, they'll confuse number of electrons and its nature. Last finally, your 5th one is N2O4, nitrogen tetroxide, same as it is. Your nitrogen and nitrogen, take here total 4 are there. Oxygen, here oxygen and oxygen. It forms like resonance, resonating structures, 2 resonating structures, same oxygen, here 4 oxygen atoms. Same here between nitrogen and there exists even covalent bond, mutual contribution, mutual sharing. Among these 4 oxygen atoms start at any one place. Here double bond maybe, here there exists a double bond like this. Now here 2 pair of electrons are present. So around the nitrogen atom total 5 are there, out of 5 3 are completed, remaining 2 are there. These 2 are donated to this oxygen atom, it forms a coordinate bond like this. Same situation here also as it is. Now here lone pairs 2. Now here 1 lone pair is donated to the oxygen. It forms a coordinate bonds. Now either side, either this side or this side, fix constant one bond like this. I'll fix here double bond like this. Now here coordinate bond. On oxygen here 2 lone pairs, here 3 lone pairs are there. Now just change this redistribution. Change this means here coordinate bond, here double bond. That's all. Clear. That is the difference between these two. Between nitrogen single bonds. Now here coordinate bond here, double bond between these. Everything is clear. Planar triangular planar structure. Here also, once we can observe around this or around this, no unpaired electrons. Number of unpaired electrons are 0 unpaired electrons. There is no electron. That's what is say diamagnetic in nature. This is a planar or a triangular planar structure. Last, finally, sixth one is N2O5. This is. Here one oxygen atom is increased. Just guess it. One oxygen atom is increased means between nitrogen and nitrogen, one oxygen atom is placed. That's all. Remaining everything here oxygen, oxygen. Here oxygen and oxygen. Here don't take nitrogen bond. Better you take here between nitrogen and oxygen one bond. Oxygen and nitrogen one bond. Don't take nitrogen and nitrogen. Then remaining edges are same. That is the difference between N2O4 and N2O5. Then here there is a double bond and here coordinate bond. There is a double bond and here one coordinate bond. Same as it is here oxygen, nitrogen and nitrogen. Here between these there is a bond. Now here constant oxygen and nitrogen. Here a coordinate bond between nitrogen and oxygen. But change here. It is a coordinate bond. Here it is a double bond. These are the 6 important oxides resonating structures. Very, very important. Based on this, maybe in objective, guarantee one question. If they'll ask correct resonating structures of corresponding oxides of nitrogen. To get the clarity about resonating structures, compulsory one idea we want. One idea means about number of valence electrons, number of paired and number of unpaired electrons, and sharing between two atom of elements to get the stable octet electronic configuration. Based on that resonating structures, based on paired and unpaired electrons, magnetic behavior important, and geometry of the molecule based on their bond angles. Next, very, very important, guarantee one question. Time remaining 10 minutes time is there. I will explain that very, very important question. Guarantee question. Either ammonia or nitric acid, any one. Among these two questions, one question is fixed in PUC in 12th standard. Question number 20. That is, first one is oxoacids or oxy anbodu. Oxoacids of nitrogen. Here 3 important oxoacids are there. One is hyponitrous acid. Formula is H2N2O2 like this. Here its oxidation state is +1. So here the oxidation state of nitrogen is +1 oxidation state. Second one is nitrous acid. Formula is here H1O2. This is in this nitrogen oxidation state is +3, because here -2 into 4 -4 here +1. Composite is +3. Nitrogen oxidation state. Third one is nitric acid. That nitric acid is HNO3. Its oxidation state of nitrogen in nitric oxide is +5 oxidation states. So based on these, very important for objective, very important question, objective question. Here anhydride of HNO2 is N2O3. Anhydride means remove the water molecule. From HNO2 will get N2O3. Maybe for objective, very important question. Maybe they'll ask in examination. The anhydride of N2O3 is anhydride of nitrous acid is N2O3. Here HNO2 on heating, it liberates water molecule gas here N2O3. Here 2 moles required. From here nitrogen and oxygen, it gives N2O3 plus water produces, water evaporated. We'll get the oxide, that is nitrogen trioxide. And another one is, second one is anhydride. Anhydride of HNO3 is N2O5, nitrogen pentoxide. Very important. Now here the 2 moles of HNO3. Here on heating, water eliminate H2O. Here it gives N2O5 plus water. Here we can write here. No need to write here. Minus is there here. Here N2O5. And another important third case is anhydride of HNO2 as well as HNO3 is N2O4, nitrogen tetroxide. So the combination of HNO2 and HNO3 on heating, heat these two molecules, will get N2O4 plus water molecule evaporates. These are very important 3 cases for objective, particularly not for theory. Objective very important. Anhydrides of nitrous acid, nitric acid, combination of both nitrous and nitric acids. So among these all 3 in our syllabus, very important question is this nitric acid. 3 marks guarantee question this is. So based on this, oxoacids of nitrogen, here nitric acid is very important. Nitric acid formula is HNO3. In the laboratory, small scale, first method in lab, we can prepare by using nitrates, sodium or the potassium, like sodium nitrate or potassium nitrate KNO3. By using this, we can prepare the small scale HNO3 in the laboratory. Now, here NaNO3 is reacted with concentrated sulfuric acid H2SO4. This is concentrated on heating in a glass retort. In a glass retort, it is heated in the laboratory. It gives here the NaHSO4. Sodium bisulfate is formed plus HNO3 nitric acid is obtained. Or if you can take potassium, here the KNO3, H2SO4 concentrated in a glass retort on heating, will get potassium bisulfate plus HNO3 is formed. So this is the simple laboratory method for the preparation of nitric acid. Very, very important. Next question is 3 marks guarantee. That is manufacture of nitric acid by Ostwald's process. Three marks question it is. Explain the manufacture of HNO3 by Ostwald's process. By Ostwald's process. In this Ostwald process, mainly it involves the following three steps. First one is oxidation, that is called a catalytic oxidation of ammonia and H3. So whenever the ammonia is heated with excess amount of pure and dry oxygen, in the presence of suitable catalyst, it gives a corresponding oxides of nitrogen. Already in the preparation of oxides of nitrogen given, NO, nitric oxide. Here 4 moles of NH3 reacted with 5 moles of oxygen. It is a gas. In the presence of lithium or platinum catalyst, and here the temperature is 500 kelvins and pressure is 9 bar pressure. Now this catalyst is a solid catalyst. Yeah, the catalyst is solid, reactants are in gaseous. That's why this reaction is called a example for heterogeneous catalysis. That is corresponding water, here the 6H2O plus, and here the 4NO is formed. This is nitric oxide gas is produced. In second step, second one is again here oxidation of NO to NO2, nitric oxides to a nitrogen dioxides. So the obtained nitric oxide is reacted with oxygen, excess amount of oxygen. On heating, we'll get 2NO2, nitrogen dioxide is formed. A reddish brown color nitrogen dioxide. Now in third step is hydrolysis. Hydrolysis of NO2 gas, a reddish brown color gas. The obtained here NO2 gas is reacted with 3 moles of water molecule against HNO3 nitric acid plus again it forms nitric again here take 3 moles here 2 moles of this and here NO gas is produced. The obtained gas is again recycled like this again. So the recycled excess amount of NO nitric oxide again oxidizes to a nitrogen dioxide. The obtained nitrogen dioxide again reacted with water. Hydrolysis reaction takes place. We'll get nitric acid. The obtained nitric acid is 61% nitric acid, HNO3. Yeah, very, very important point is last the obtained nitric oxide here the concentration method here. No need to write in PU for 3 marks, only these 3 steps enough. The obtained here the 61% HNO3 by using fractional distillation in a round bottom flask, fractional distillation on heating, here will get 68% HNO3. By using fractional distillation, won't get any 98 or 100% because it forms a azeotropic mixture, constant boiling point mixture. Then again it is treated with dehydration takes place. Yeah, the dehydrating agent is here concentrated H2SO4 acts as a dehydrating acid. You'll get 98% HNO3. This is pure concentrated 98% HNO3. This is the manufacture of nitric acid by Ostwald process. Very, very important. Among ammonia or nitric acid, guarantee one question for 3 marks. In ammonia, same catalytic conditions and flow chart and reaction important there. Here compulsory these 3 important steps. Any creativity is there for you? Better you create some statements, heading and write something. When ammonia gas is reacted with pure and dry oxygen gas, in the presence of all these, it gives corresponding NO. Then write the reaction. The next step, heading is oxidation of NO2 to NO2. Yeah, this nitric oxide is reacted with pure and dry oxygen, it gives nitrogen dioxide. Then write the reaction. Same thing, hydrolysis of NO2 reacted with this, it forms 61% nitric acid, and nitric oxide is formed. That is again recycled, again repumped by using related equipments. Then again oxide is converted into NO2. Then the obtained nitric acid is again converted into 68 by using fractional distillation. Then again converted into 98 by using dehydration by using concentrated sulfuric acid. Okay. Last, finally, in nitrogen, only one important concept is there. Chemical properties, uses and structure of nitric acid. Tomorrow maximum I will complete this nitrogen part, and I will start P, phosphorus and its compounds. 1 or 2 classes maximum. Better you read. Today we will send NCERT textbook P block elements chapter as well as college material. Through that, better you cover it. Okay, take care.